One of my students asked me to solve this problem. This is from Mathlab, and we are supposed to find the domain and the range of the function. And before we try to answer, I know it is a multiple choice question in Mathlab, but I'm going to try to explain it from scratch. Okay. And as we have done in the classroom, we have to understand the transformations. Let's try to graph it. Now, you do have to understand this one thing very well. This is from your transformation notes. Okay. This is going to be a vertical compression. I'm going to show you, but this is not going to have any impact on the domain or the range of cotangent function. Okay. And you have to go to Desmos and play around and do all that. This will be a move up by 2 units, vertically going up. The entire graph of cotangent x will vertically go up, or whatever else for that matter. This will also not impact the range or the domain. You can practically ignore this. What about this? Now, this one is the trickiest one. You know that. 1/4 as a coefficient of x is a horizontal stretch. Once again, it's a horizontal stretch. It's going to stretch the curve away from the y-axis in opposite directions. Okay, I'm saying it very carefully. I'm trying not to make a mistake. 1/4, and you have to look at this and play with it and have a good understanding of it. Again, multiplying x by 1/4 or dividing x inside the function by 4 will have a horizontal stretch in opposite directions away from the y-axis, like so. I'm going to do a little sketch here. This is the y-axis. It's going to go like this. Okay? And you have to understand these bits and pieces. Let's explore cotangent x on Desmos, okay? Of course, I'm going to play with it, but this is the main graph. Okay, cotangent x looks like this. You can zoom more. This is roughly what it looks like. Now, what you're really interested in is understanding the range of this function is from -infinity to +infinity. Okay, and as we have discussed, none of the three things we did will have an impact on the range. So the range will be the same. Okay, I'm going to write it down here. I'm going to eventually move to that curve, and hopefully I'll remember to refer to it. The range will be this will be the range. Once again, the range does not change because this doesn't affect the range. The 1/3 does not affect the range. It's a horizontal compression, and 1/4 is, 1/3 is a vertical compression, and 1/4 is a horizontal stretch. None of them affect the range. This is my answer for the range. Okay, now I'm going to carefully, you have to understand, I'm going to pretty much ignore the +2. Doesn't affect anything. Okay, so I'm really going to be interested in this graph. Let's do the graph again. I'm really interested in this graph. I'm really interested in this graph. Let's go over here and see what we can do. Let's do our y is equal to 1/3 cot x. Now, this is a vertical compression. So basically what they're doing is they're pushing the red curve towards the x-axis from both directions, up and down. So it's being squished. The red curve is being squished towards the x-axis. And that's what we mean by vertical compression by a factor of 3. Again, as we said, it does not impact the range. It does not impact the domain. Okay, now we're gradually moving towards the domain. So for the domain, you don't need this. Okay, 1/3. You could practically, I don't need this curve anymore. I do know, I did acknowledge. Well, before actually we do one thing, let's find the domain of this red function, original function. What's the domain? I can totally see. Let me take this picture here, if you don't mind, for now. This is not my final picture. I'm going to take this guy. And put it here. Now I'm going to carefully write down the domain of this curve. It seems like the domain is all real numbers except for 0, pi, 2 pi, 3 pi, 4 pi, and of course, minus pi, minus 2 pi, minus 4 pi, 3 pi, so on and so forth. So let's write it down carefully. Okay. Domain. All real numbers except 0, plus minus pi, plus minus 2 pi, plus minus 3 pi, comma, dot, dot, dot. I'm going to explain your answer choices on Mathlab in a second. This, I'm going to highlight it so that this is really not my answer, and my answer will change, and I have to be aware of that. Let's make it yellow. That means this is not my answer. It has to change. How will it change? Remember, guys, 1/4, multiplying x by 1/4 will affect the domain, and multiplying something by 1/4 is a horizontal stretch by a factor of 4. We're going to, of course, test it. Okay, so it's a horizontal stretch. Let me grab this curve, okay? Let me grab this curve so that we can show you why it's a horizontal stretch. No, excuse me. Okay. All right, so this is a horizontal stretch. It looks like, it kind of makes sense to me that this is 1 and this is going to be 4. Okay, so all these places where you have vertical asymptotes, okay, will be multiplied by 4. You can say it will be divided by 1/4. Dividing something by 1/4 is same as multiplying it by 4. Okay, so we are going to rewrite the new domain correctly. Let me actually explain this to you a little better. Why? How do I know for sure this is a horizontal stretch? Take a look. This point, make it a little thicker. Goes here. And trust me, guys, This will be 4 times. Okay, if you don't believe me, you pull out a ruler, freeze the video, and measure it. Okay, this red line will be 4 times the black line. All these points, pi, 2 pi, 3 pi, and 0, they will be stretched. They will be 4 units away from the y-axis. All right, so it's like multiplying it by 4. Let's copy this. I don't need this. Let's copy this. And let's fix it. Okay. So this will be divided by, multiplying by 4. Excuse me. 4. This will be 8. This will be 12. Now, the way the answer shows up in your book, it basically says, let's put it here properly. Let's put the curve there. This is my answer. Now, this is so basically 4 pi, 8 pi, 12 pi is another way of saying it's a multiple of 4 pi. Okay, 4 pi, 4 pi times 2, 4 pi times 3, 4 pi times 0. So it's actually a multiple of 4 pi. Everything you see here, including 0, is 4 pi times an integer. What are integers? 0, plus minus 1, plus minus 2, plus minus 3. So that's what your answer should be. So we're going to see where we can go from here. Not a problem. We'll have to find this guy here. Let me go back, open a new GeoGebra, and we'll be on our way. So based on our discussion, the domain has to be, let me see if I can make it a little bigger for you guys. The domain has to be B because it's X such that X is not 4K pi. So replace K with 0, you're going to get our 0. Replace K with plus minus 1, you're going to get plus minus 4 pi. Replace K with plus minus 2, you're going to get plus minus 8 pi, so on and so forth. And clearly, the range is all real numbers. Of course, we wrote it from negative infinity to positive infinity. So I would go with B and B for this one. I hope that helps.